Right, going to the last part of this wave chapter, how is sound useful? So I'm just gonna point out one important part. Other than that, the rest are all just reading. You can just read it on your own using the textbook, or just search some online videos that'll be fine. So I will provide some links, but other than that, you can just do your self study, right? It's just a application of that concept in real life. So now this is a picture of an ultrasound image. So have you thought about uh how come ultrasound, which basically is just uh sound waves, right, that are above the human audible range, or aka 20,000 hertz, right? Right? How come we use sound wave, or how come sound wave can generate an image in the first place? Right now, the answer comes from the idea of echo, right? Where basically, uh, sound is reflected off a surface, and then when it reflects back to, let's say, a detector, right? The amount of time that it takes will be recorded. The distance that it travels will be uh noted as well, because the speed of sound is constant in a fixed medium, right? So if let's say speed of sound, right, you know the speed of sound of something, right, you can use it to determine, let's say, the distance. Or if you have a given distance, you measure the time taken it takes for the sound wave to travel and come back, right? You can use it to measure speed of sound. So in that case, an echo, right, whereby sound travels, come back, the distance that it will travel will be 2d, right? If let's say d is the gap between your source and the reflecting surface. So in that case, speed of sound, let's say we use the letter v to represent. How can we measure that with this 2d? And let's say we measure using a stopwatch, and we recorded that, hey, the time that it takes to travel back is uh t, right? Let's say time t seconds. So in that case, the speed of sound can be calculated very easily, right, by the distance that it takes, distance that it travels in that fixed time. So 2d over t in this case, that will give you the speed of sound. And when it comes to this d, right, actually we meant that as the minimum distance, which is actually just the perpendicular distance lah, because the distance that the shortest distance that it will take to travel back, that will be the first sound you will hear, right? That will be the sound that the first echo that will come back, because the sound can travel in any direction, sure, right? But the sound that travels the shortest distance will come back to you the fastest. Okay, so yeah, actually that's all. So basically, just remember that when, let's say, you are required to calculate speed of sound, or you have to use the speed of sound to calculate, let's say, distance, just make sure that there's always this 2D factor that you are accounting for echo, because echo is about reflecting of a surface. Okay, yeah. Then the rest are just your own reading lah. So basically, let's say a bat uses sound wave to detect objects, because let's say a cave, right, it's very dark, so they can't really use their eyes. There's no light for them to see. So in that case, they navigate by emitting high frequencies of sound. So other than that, right, your ships also uses sound technology, right? It's known as sonar, which represents sound navigation and ranging technologies, whereby they emit pulses of sound into the water, then they listen for the echo. So they can measure large distance and detect location. Okay, but of course, this wouldn't be the only way to use, right? Because well, anything that goes in between can easily block the sound wave really, or send a false echo. So they also have to discern between the real one and the fake one, right? If let's say they want to measure the depth of the sea to the seabed. Okay, next one is imaging of internal organs. Okay, this one can read on your own, right? I just want to share this also because when I went for my recent physiotherapy, I realized that they actually use a sound wave as well. They use ultrasound to try and heal uh surgical wounds. So apparently the physics is here is that the sound wave will cause the skin to vibrate and generate energy. Because again, vibration of particles means that there's a higher average KE, and then that will raise the temperature of the skin. So that can help to increase the blood flow and promote healing in the skin. So other than that, can also be used to break up kidney stones and cancer treatment. Uh, Now, one thing about ultrasound, right, or rather sound wave, why do we use it for medical procedure? So let's say pregnant woman uses it to scan for their baby. Now, the reason to use that is because ultrasound is still rather harmless to human. So the energy level that it possess it's not high enough or not fatal, not lethal, such that it will cause harm to the human body. So actually is used quite widely as a medical procedure or as a medical treatment. Okay, so let's look at word example 9, a quick one. A boy makes a loud noise, sound travels at 330 meter per second. Here's an echo from a cliff. What is the distance between the boy? So if let's say you cannot visualize, right, always just draw it at the side. Just a just a rough one. So this guy is gonna clap and the echo will travel back to him. So in that case, it travels by, let's say this is the distance between the boy and the cliff, then it will have traveled 2D, two times the distance. So since V is equals to 2D over T, right? Since he heard only 1.5 seconds later, so just sub in all the values, right? D will be equals to 330 times 1.5 divided by 2. Okay, so you can do the math yourself. I have a calculator with you. Do I? Right, so the answer here 247.5 uh 3SF 248 meters. Okay, next one. This is a 10 series question. So now this is a paper one question, but you can jolly well become a paper two question. A fishing boat sends out a pulse towards the seabed and pick up two echoes, a faint one followed by a strong one. So the echoes are heard 0.5 seconds and 0.7 seconds after the pulse emitted. Velocity of sound is 1500 meter per second. Calculate the distance between the boat and the shore of fish. So actually this is quite simple also. So one is it hits the fish and it travels back up, right? But of course, because the shore of fish, right? So there are gaps in between. So that means most of the sound can actually travel through and hit the seabed before it reflects back again. So in that case, between this 0.5 and 0.7, which one do I use to calculate the distance for boat and fish? It will have to be the shorter type, right? Because travels shorter distance. So in that case, B equals to 2D divided by T. So 1.500 equals to 2D divided by 0.5. So there you have it. You have your answer, 375 liters. Now, can I give you a challenge, right? Uh, you could try to calculate the distance between the shore of fish and the seabed, right? With this information. Okay, and I mean, you can do it manually, right? Calculate both the distances, then you minus off the difference. Sorry, you take the difference, right? Or try and find if there's any other way that you can, use maybe just a one step or two step method, right? To find the answer. Okay, so I'll leave it to you if you like to take up this challenge. Right, that's all for today.